recording your class today. So like I said, combining our plan of attack from yesterday, our strategies from yesterday, and just giving you a few more and giving you examples of a few more varieties of problems. What you're going to notice is you might be able to identify, hey, that kind of looks like this type of problem we did in our notes. How did we attack it? It might not be the same functions, but if the formatting looks similar, this formatting is going to show up over and over and over. And what I'm talking about is this, that we have like a sine or a cosine in the denominator of one fraction. And in the other one, we have the other function like 1 plus or minus that function, okay? So we've got two fractions, two different denominators. One strategy for this would be to get a common denominator to add the two together. It looks a little different than the common denominators we have done before. So, reminder on our algebra rules, how we get common denominators is we have to represent all of every denominator. So my common denominator would have to have a sine of x. My common denominator would also have to have a 1 plus cosine of x. In algebra, we learned that when I am trying to adjust to a common denominator, I compare the current denominator to the common denominator and say, what am I missing? Because that's what I would multiply by. On the first one, we have a sine of x. We're missing the 1 plus cosine of x. So this one would have had to have been multiplied by 1 cosine of x. And we would do that top and bottom. This is unique. We have not seen something like that yet where it is 1 plus cosine times 1 plus cosine. When we run into something like that, it is a binomial. You must FOIL. And we just follow our rules for foiling. So 1 times 1 is 1. 1 times cosine is cosine of x. 1 times cosine is cosine of x. Cosine times cosine is cosine squared. Repeat the process over here. I have the 1 plus cosine x. I'm missing the sine of x. So this one would have had to have been multiplied top and bottom by sine of x. And in that one, it's just a sine of x times sine of x, so we get sine squared x. Yes. Yeah, so I'm like showing like all steps, but yes, going ahead, this is 2 cosine x, right? That would be like an x plus an x is 2 x's, 2 cosines, right? Absolutely. So cleaning this up, now that we have a common denominator, I can add all the way across here. So 1 and then combine my like terms here, 2 cosine x. Got a cosine squared and a sine squared. Ooh, and I did not mention this, but I would strongly suggest not distributing. Distribute. I would not distribute something like that. And we're going to see those type of things happen frequently. I would not distribute those because typically down the road we're trying to simplify with one or the other of those terms. And if we need to, you'd have to like factor that GCF back out. Just leave them sitting next to each other, okay? And we're going to see that several times today, so you'll kind of pick up where that happens. Anytime it's these type of things sitting next to each other, just leave them next to each other. Okay, in the top, scan through there. Does anything jump out at you? Cosine squared plus sine squared, right? There is that Pythagorean identity, and every time we see a squared with a plus or minus, we scan through for those Pythagorean identities. So cosine squared plus sine squared, that is 1, which means this whole term right here is 1. Well, 1, combine my like terms, right? 1 plus 1 is 2. We're getting closer. What can I do to that numerator? Take out a 2, right? It has a GCF of 2. Factor a 2 out of each of those terms, leaving us with 1 plus cosine x, and now it's starting to look like something that we can work with here, right? We talked about this yesterday. as long as it's attached to the same thing, 1 plus cosine and 1 plus cosine, is if I find the same thing top and bottom, we get to eliminate or cross those off. They simplify, leaving me with 2 over sine of x. We don't want it to look like a fraction, so instead I would write it as what? Instead of over sine? Cosecant, right? A sine in the bottom is like a cosecant. So this would be 2 cosecant x. Okay, that one was very different. So we're going to pause. I want you to kind of scan back through. And if there's anything up there that is not making sense, like I'm not understanding where we got that, where did this line come from? We simplified a lot from here to here, all of those kind of things, let me know. You're going to see this one show up multiple times. Any questions? Okay, strategy 2 today. I am going to show you a problem just like this in like 2 slides as well, and we're going to talk about side by side the difference in how I would attack these problems, and it is 100% which function is being added. So in the denominator of this one, if it is a 1 plus, 1 minus, it doesn't matter if there's some sort of 1 plus or minus in there, and the function after it is secant, cosecant, tangent, cotangent, I would attack it this way. I would attack it like we're going to do this problem, and that is to get a common denominator in the bottom of our fraction. So replace with identities to get a fraction. I would get a common denominator. I would make it one fraction. And then multiply by the top by its reciprocal. Okay, so let's see that in action. When I say replace with sines and cosines, cosecant, I can replace with 1 over sine. So I'm going to focus on the denominator for quite a while here. Get a common denominator so that we can add those 2 fractions in the bottom together. And again, if it's a 1 and I want a common denominator, it's going to end up being sine over sine. And I can show that work here if I want to, multiplying top and bottom by that. Put them together to be 1 fraction now that we have that common denominator. Once it's 1 fraction in the bottom, you can always multiply then by its reciprocal, right? So anything from the bottom, if I want to get rid of it, I can multiply by its reciprocal. And so to do that, I would take the numerator, which is 1 plus sine of x, and we're going to multiply it times the reciprocal of this guy, which would be sine of x over sine of x plus 1. Okay, what can I do now? Cross them off. Does it bother anybody that it's not the same order? Maybe. This says 1 plus sine of x, and this says sine of x plus 1. Is it okay that they're opposite orders? When is it not okay? If it's a subtraction, it's not okay to flip the order. If it's addition, it is. So yes, I get to cross these off, multiply straight across the top, straight across the bottom, and we get a sine of x. So remember, anytime it says anything other than sine or cosine, so 1 plus tangent, secant minus 1, any of those situations, anytime it is one of the secant, cosecant, tangent, cotangent, along with a plus or minus 1 in there, this is my plan of attack for those type of problems. Okay? Look at the denominator of this one. Doesn't it look so similar to the denominator we just worked with? Right? So if I flip back and forth, you've got a sine squared over 1 plus cosine. If I flip back and forth, 1 plus cosecant, don't those denominators look real similar? The difference is what the function is. This time it's a cosine, so not one of my 4 options that I just talked about on the last page, not a secant, cosecant, tangent, cotangent. First of all, there's not a good option to make this a fraction because we don't really want to change things away from being a sine or a cosine. Okay, so if it is sine or cosine in that place, along with a plus or minus 1 somewhere in there, I would use what's called the conjugate. So here's our next strategy. Now, we've seen that word show up in here at least 2 different lessons throughout this year. Getting rid of radicals in the bottom of our fraction, getting rid of imaginaries in the bottom of our fraction. We use that thing called a conjugate. Do we remember what that is? No. A conjugate is this with the opposite sign. Okay? So anytime I see that, I'm creating a difference of squares is what I'm doing, is I'm going to take this bottom of my fraction, but instead of a plus cosine, I'm going to put a minus cosine. So it'll be 1 minus cosine of x. And I can't just do that to the bottom. Remember, we have to do things to the top and the bottom. This is the same idea of what I was talking about earlier on something like this. Don't distribute. Okay? Don't distribute that, guys, because eventually we're trying to simplify this fraction. Leave it pulled apart. Leave it so that we can simplify with something that's going to show up in the bottom of our fraction. Remember that I can FOIL this. That is a difference of 2 squares. It behaves the exact same as every difference of 2 squares. It'll end up being the first thing squared minus the second thing squared. But if I forget and I FOIL, guess what? We get the right answer anyway. So 1 times 1 is 1. That'd be minus cosine of x plus cosine of x minus cosine squared. And your middle terms will always cancel. And we'll always get the first thing squared minus the second thing squared. 1 minus cosine squared of x. Okay. Always when we've got that squared plus or minus, though, we look for our Pythagorean identity, and I can replace 1 minus cosine squared with sine squared. Then I have a sine squared in the top and the bottom that I can simplify, leaving me with 1 minus cosine of x. Now, this is something that I would make a note for myself in my notes about. At this point, this problem is done. And this is the first time that we have stopped a problem where there's still an addition in there, more than one term. We don't see it often. But guys, if it is involving a sine or a cosine, there is nothing else you can do at that point. Okay? If it was a secant, cosecant, tangent, or cotangent, we could get it to be one fraction and add them together, but we can't on this one. So there is nothing further you can do on this one. And that is one of my very solid reasons that I will continue to say that 5.1 is the hardest section that we will do. Because there is no, like, I'm sure I'm done with this problem point on a lot of problems. And unfortunately, it's just trying them out over and over. And I can tell you that because I've now taken this class at least 3 times for the last 9 years. And I've done these problems a bazillion times. That doesn't go any further. I've tried, okay? You can't simplify that any further. And it just takes practice to learn when that is, all right? Okay, last one today that I want to go through, something like this. 1 plus cosecant x over cosine x plus cotangent x. Again, as I see problems like this, I would, again, in my head, view this as 2 fractions on the top, 2 fractions on the bottom, get common denominators so that it's 1 fraction on the top and bottom, and then I can multiply by the reciprocal. And so on this one, it would just end up happening in both places. Common denominators in the top, common denominators in the bottom. Because both of them can have denominators, right? Cosecant can be 1 over sine of x. Cotangent, cosine of x over sine of x. So a lot of common denominators to get in this one, different for the numerator than it is the denominator for the original fraction. But we'd be looking at multiplying by sine of x top and bottom here, which would give me sine of x plus 1 over the sine of x. Did I go too fast through that top part? Okay. In the bottom, this one gets a little ugly. Sine of x here to get our common denominator, which is going to give me a sine of x cosine of x plus cosine of x over our common denominator, sine of x. Questions? Good. Okay. I now have it 1 fraction over 1 fraction, right? So I can at this point take the numerator, which is our sine of x plus 1 over the sine of x, times the reciprocal of that denominator fraction, one of the things is very obvious. I can get rid of a sine of x top and bottom. The other part of the simplifying is this is not as obvious, so we'll see if somebody can figure it out for us here. There is one little thing we can do that actually will allow us to simplify this further. Yeah, take those cosines out, right? The bottom has a GCF. If I factor a cosine out of each of those two terms, pull that out front, I would be left with a sine of x. And again, I take a cosine out of this, I would still have a plus 1 there. And you can see that our sine of x plus 1 and our sine of x plus 1 would cancel. Remember, it is still 1 over, though. That cosine of x does not just magically move to our numerator, and I don't want it to leave like that. Secant of x. Okay, any questions for me? I do want to just, again, reiterate, because I get this question frequently, so I want to make sure that we are very clear. Look at the two denominators that you see up on the board. 1 plus cosine of x, 1 plus secant of x. They appear to start out the same. And what happens is I would really like to do my conjugate here, but it's not necessarily in our best interest over here. It might be, and there is a path, and you can try it, but it may not help you. So remember the difference in how I would attack these. On this one, I would use my conjugate and multiply by 1 minus cosine of x. Over here, I would get a common denominator and multiply by the reciprocal of that bottom fraction. So I would rewrite the denominator as 1 over cosine of x and get this to have a common denominator and multiply by the reciprocal. So the difference between, and the reason being, is this function. If it's a sine or a cosine, conjugate. If it's anything else, common denominator, multiply by the reciprocal. Yes? Attached with a plus. You cross off this 1 and this one? Yeah, because it's attached with a plus. So either it has to come with a cosine attached to it, or we can't cross it off. Other questions?